Standard 12th Maths Chapter 5 Exercise 5.2. This is from NCERT book. Question number 9 and 10. Prove that the function f given by f of x equal to modulus of x minus 1. X is in a real number and is not, you have to show it's not differentiable at x equal to 1. Let us see the definition of this x minus 1, modulus x minus 1. This is equal to minus x minus 1 for x less than 1 at x equal to 1, no? Then it is plus x minus 1 for x greater than 1. This is, we define the modulus of x minus 1. And also this is continuous. F of x is a continuous function. Continuous function, that is x-axis, y-axis here. So whatever value we give for x, suppose if I give value for x as 1, 1 minus 1, 0. So the y value is 0. So you are getting the first point here, 1, comma 0. And then if I substitute x as 2, 2, comma 1 is 1, I will get here. Actually, come to the negative side, minus 1. If I substitute x as minus 1, minus 1, minus 1, minus 2. So minus of minus 2 is plus 2, you will get here. So for negative value also, see minus 2, minus 1, minus 3, minus of minus 3 is plus 3. So you will get here. So for positive value of x and negative value of x, you are getting only the positive value of y in the modulus. So here I will get this side. So see, minus 1, here you will get here and here will get. So it is for whatever value we give for x, corresponding y value getting. So f of x is a continuous function. Now we have to show it's not differentiable at x equal to 1. So not differentiable. So for differentiable function, f of x is, suppose it is differentiable at x equal to c. So you will get limit x tends to c. This is the formula, x minus f of c divided by x minus c. Okay, now I'm going to prove that it is for at x equal to 1. F of x is not differentiable. Not differentiable at x equal to 1. That is, limit, you have to prove, that is, we have to prove negative side of this f dash of 1 minus is not equal to f dash of 1 plus. I have to show this. First let me take left hand side, f dash of 1 minus. This is according to the formula, limit x tends to 1 minus. So 1 minus function f of x is modulus of x minus 1. Modulus of x minus 1 minus here if I substitute f of c is here 1. F of 1 minus 1 is 0 divided by, just write this, x minus 1. That is equal to limit x tends to 1 minus. So 1 minus negative side of x less than 1 means the function defined as minus of x minus 1. So minus of x minus 1 divided by x minus 1. So this is equal to limit x tends to 1 minus x minus 1, x minus cancel, so minus 1. So no need of substituting the value for x. So I will get minus 1. Take the right hand side, f dash of 1 plus, that is limit extends to 1 plus f of x minus f of 1 divided by x minus 1. See, the function is x minus 1. So for 1 plus, positive side, for x greater than 1, we get the function as x minus 1. So limit extends to 1 plus x minus 1, and substitute x as 1, you will get 0, minus 0 divided by x minus 1. This is equal to limit extends to 1 plus x minus 1 by x minus 1. That is limit extends to 1 plus, this is 1. No need of substituting for x, so you will get answer 0. Mark this as 2, right hand side. This is left hand side, 1. So for left hand side value, we get minus 1. For right hand side value, plus 1. So 1 is not equal to 2. That is left hand side is not equal to right hand side. So f of x minus is x, we can take 1. F of 1 minus is not equal to f of 1 plus derivative dash. Therefore f of x is not differentiable. Not differentiable at x equal to 1. So this is the answer. See, very easy for you. We define the function and we showed it is continuous. Once the function is continuous only, we say it is differentiable, and we check for differentiable. This is the formula, and we take here x value as 1 minus, because at x equal to 1. So left side limit and also right side limit. For x 1 minus and 1 plus we take. Both the sides should be equal if it is differentiable. So not equal, so it is not differentiable at x equal to. See the 10th question. Prove that the greatest integer function defined by f of x is just bracket greatest integer function x, where x lies between 0 and 3, is not differentiable at x equal to 1 and x equal to 2. We have to discuss with the two values. First, we will see what is greatest integer function. F of x is a greatest integer function. Integer function. See, the function is defined, we define for the interval 0 to 3. Here 0, 1, 2, 3. You can discuss just for this. So f of x is close bracket x. So f of 1. So the greatest integer is 1. F of 2, greatest integer is 2. Just 2. Take the decimal value 1.5. That is close bracket 1.5. So 1.5 lies between 1 and 2. This is 1.5. So you have to see that greatest integer. See decimal value. So 1 is integer, then 0.5. So the 1 is the maximum integer, greatest integer. So answer is 1. Take f of 2.7. Close bracket 2.7. So 2.7 lies here, 2 to 3, 2.7 here. So the greatest integer here is 2. It lies between 2 and 3. So answer is 2. So this is the meaning for the greatest integer function. And we are going to prove that it is differentiable at x equal to 1 and x equal to 2. So we have seen the definition of the differential function. F dash of c is equal to limit x tends to c f of x minus f of c divided by x minus c. So here what I do, I take the neighborhood of this point. Actually, x is the greatest integer function. I take neighborhood of this point, that is limit, so f at x equal to 1 minus, so left side of this. So limit h tends to 0. So we take the neighborhood of this function. So left side of this 1 minus h minus f of c is here 1 divided by x minus this. So 1 minus h, then c is here 1. So you will get here limit h tends to 0. Actually x takes the value 1 minus. So f of 1 minus h. So this is equal to, just we write it as closed bracket of 1 minus h. 1 minus h. F of 1 maximum value, we see that greatest value is 1 divided by minus h. So this is equal to, here, see what is this 1 minus h, greatest value. So 1 minus h lies between 1 and 2. Here actually 1 minus h. So it is less than 1. If I subtract from 1, you will get here 1 minus h. So what is the value, greatest integer here is 0. So we write here limit h tends to 0. 0 minus 1 by minus h. That is limit h tends to 0 minus 1 by minus h. Minus minus gets cancelled, 1 by h. Substitute h as 0, 1 by 0, that is infinity. This is your left hand side. For the right hand side, you take the function as here. I have seen that h tends to 0, x tends to 1 minus. Here limit h tends to 0, x tends to 1 plus. Therefore, f of 1 plus h minus f of 1 divided by x minus c. That is 1 plus h minus 1. So here you will get here limit h tends to 0 of 1 plus h close bracket minus f of 1 is 1. So 1 gets cancelled, you will get h. So limit h tends to 0 of 1 plus h. It comes after 1. After 1 is 1 plus h. So the greatest integer is here 1. So 1 plus 1 minus 1 by h. That is limit h tends to 0. 0 by h. What is the value of 0 by h? 0. So we no need to apply the h value as 0. So just answer is 2. See the left hand side answer 1 is you are getting infinity. This is your left hand side and this is your right hand side. So 1 is not equal to 2. So left hand side is not equal to right hand side. So f of 1 minus is 1 minus is not equal to f of 1 plus. Therefore, f of x is not differentiable. At x equal to 1. Same thing you prove for x equal to 2. At x equal to 2. So just directly you take that limit h tends to 0, x tends to 2 minus. So formula is f of x. F of x is 2 minus, that is 2 minus h. You start from this step here, okay. 2 minus h minus, see f of 2 minus h minus f of 2 divided by, formula is x minus c. Here x minus c, that is 2 minus h minus 2. C is 2 here. So this is limit h tends to 0. You can remove this x limit because no x value here. Close bracket. 2 minus h minus 2. 2 gets cancelled, minus h. So limit h tends to 0. 2 minus h. 2 minus h is here. It lies between 2 and 3. Here you will get 2 and 3. So I already explained to you for 2.7 it is 2. So here you will get 2 minus h. So it is 2. So substitute 2 minus h as 2. And this is 2. Just 2. And divided by, it's just one correction here. 2 minus h. 2 minus h is here. It is less than 2. Here 1 and 2. So you will get here 2 minus h here you will get. So less than 2. So that is its value is 1. Sorry, its value is 1. And this is 2 divided by minus h. So limit h tends to 0. Minus 1 by minus h. Minus minus gets cancelled. Limit h tends to 0. 1 by h. So apply the limit value for h. 1 by 0. The answer is infinity. Take the right hand side. Limit h tends to 0. X value is limit x tends to 2 plus. That is f of 2 plus h minus f of 2 divided by 2 plus h minus 2. So f of 2 plus h. 2 plus h means it just after 2. 2, 3. 2 plus h after 2 here. So the greatest integer is here 2. You will get 2. Limit h tends to 0. 2. F of 2 is also 2. Divided by 2 gets cancelled h. So limit h tends to 0 of 0 by h. What is 0 by h here? You will get 0. So no need of substitute for h value. So the answer is 0. This is 2. So from 1 and 2, left side is not equal to right side because left side value is infinity and right side value is 0. That is f of f of 2 plus. You can take it as f of 2 minus is not equal to f of 2 plus. Therefore, f of x is not differentiable. Derivative dash f dash. Differentiable at x equal to 2. This is the answer. So just have an idea, go through this. You can get easy one. Thank you.